So there was a project. Apparently it caused some fun discussion. That's good. So I remember when I first pulled the numbers and pulled the data off of those videos, I remember feeling very depressed when we got to the end result. But did anybody read all the way through to the last footnote to see my true depression? Yeah, it's funny because somebody talked to me. Somebody told me that. I didn't believe it until I looked it up myself. And then they said, but dude, the ocean, not only that, but the ocean leaches at least as much oil as BP did. The ocean leaches it itself every year.
That's weird.
And I said, okay, but it doesn't leach it all on Mississippi. I mean, that was my counter to that. And they're like, okay, well, I have a point there. And then I went and Googled their, oh yeah, go ahead. Oh, okay, ask the question, got it. So, I mean, it's like a double-edged sword project because it's wicked interesting because it's a neat way of dealing with very, very goofy data that you can't deal with otherwise. It's fun. But it's also really depressing by the time you're done. You're done, you're like, okay, no, I don't want to go back and roll back into bed and stay in bed the rest of the day. Because, you know this. But anyway, the idea is it's one more tool for your toolbox in case you're in a research study. And this happens a lot. I bring this up a lot with people that are doing research studies for PhDs. I tried to use it just recently with my friend Justin. Justin Borowski, you guys might know him. He teaches here. He just got his PhD in hostage negotiations. Totally rad. He had 9 data points. But I couldn't use bootstrapping on it because it was purely qualitative data. And I couldn't use any kind of metric measurements like that. I had to code stuff and feed it through other regressions. But it's very, very handy when you've got extraordinarily small data sets that are really, really, really erratic looking. You just create, assuming you've got good data, and that's the other thing too. I assume that these data were good because I relied on a machine to measure them. Did everybody check out the software that was used? I forget what it's called now, the tracker software. It actually identifies, if you have a video that has motion in it, it finds a particle in the video and tracks the particle, and then if you give it a metric of distance in the video, it can figure out how fast the particle is going. Now that's pretty cool, assuming that the video is in real time. So that's what you do, you can look at that pipe and say, the pipe was 14 inches, I think, right?
Yeah.
So that pipe is 14 inches, assuming it's not distorted on the film. Then you track the particle, and it knows, okay, if this is 14 inches, and it covers that distance in 1 second, it's going 14 inches per second. And that's where those numbers came from. It's actually really, really slick to get that kind. Michael, go ahead.
But that only works if it's going directly sideways.
That's why there's only 6 data points, because it took a while to find the 6 that were going in the correct direction. Now, I say correct direction. There's also some error built into that, because it's what appears to be horizontal. Here, Michael say if it's coming towards you or at a diagonal, you're actually getting either a slower or a 0 velocity. But what's interesting is, I'm pretty sure we did it at most correctly because we actually captured the amount in our interval that they actually said leaked. That's the part that I think is totally rad. We actually have essentially the parameter at the end because BP told us what it was. Assuming they're correct, right? Assuming they're correct. Eventually, after about the 2nd or 3rd week of that, you guys remember that? It was like 4 years ago, I think. After the 2nd or 3rd week, they started putting reports up on the website, like daily reports of what happened. And they talked about gallons of oil they had recaptured, and barrels of natural gas that they torched. They actually burned quite a bit of natural gas off because I guess they couldn't reclaim it for whatever reason. I don't fully understand that. Oh, Sarah, go ahead. You know.
Well, it's just different. And I lived in North Dakota for a while.
So you know what's going on with as far as the mining goes. Go ahead.
Yeah, my husband was an oil fracker.
Gotcha.
They burn off natural gas just because it's easier to burn the natural gas off while you're fracking full oil. And like you're driving down the road and it's just like pillars of natural gas.
Just burning off.
It's constant gas. So,
Yeah.
I mean, it's like it's more common that they're burning.
That's not natural gas though. Well, I guess it is methane. It's methane. You're right. Well, wait, but is natural gas methane or is that something else?
No, it's propane.
That's propane,
There's
right?
tons of methane.
But wait a minute now. Why not collect it though?
It costs more money to collect it than you can sell it for. It's like you get the oil faster.
Oh boy, hippies don't like hearing that. Hippies don't like hearing that. Okay, I'm gonna pretend I didn't hear that. No, I'm gonna go back over here. We're gonna talk about bicycles. We're gonna talk about bicycles. Sorry, Sarah. I adore you. Thank you for telling me that. I'm gonna forget that I heard it now. Brandon, if you don't mind. Whew. So anyway, that project never ceases to bum me out, and it's okay because it's great mathematics, but it's also extraordinarily. It hurts. It hurts in a lot of ways when you get the results. But what's powerful about it is nobody said statistics has to be pretty. but it should be accurate. And that's the point, it should be accurate. And that brings us to the point of today, which is we need new tools to measure new things. And this happened to me, I'd say about 2 months ago, and I figured this is a perfect segue for where we're headed. You'll need your data sheet eventually. We have lots of data sets, but I'm going to start with one that I collected with my son. So I finally got a cyclocross bike, finally, after 20 years of bike commuting, and tired of ruining my road bike and slogging up the hill on my mountain bike when the roads are good, and ruining my road bike on days like today. And I finally bit the bullet, went to Repeat Performance and got a used GT. I forget what the line of this one is. It was a used guy at Repeat Performance. Great little used sporting goods store. We've got Gear Peddler at Repeat Performance. Fantastic little stores.
Repeat's cheaper.
Well, sometimes. Depends on what you get. So this was a sweet, sweet bike. But I got it and I loved it right off the bat. Took it for a test ride right off the bat. I'm like, that's great, 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 great. But this made me nervous. This and this. And I want to show you why. So those are called cantilever brakes. Cantilever brakes, if you don't know anything about bike brakes, that's totally fine. I'll show you a picture over here in a minute. Cantilever brakes are like an old school lever actuated brake. I think it was the first design of a lever actuated brake. And essentially, I'll show you here. Picture here. So that's a cantilever. So you pull the brake lever on your bike, that goes up. That goes up, pulls this diagonally up, pulls the arms up, brakes go in. So a lot of moving parts, and also some physical issues on cantilevers because it's not, the brakes are getting pulled at an angle, if you will. The cables are being pulled angularly, which means the force that's being exerted upward is not the entire force that's going in on the side of the brake. So if you pull, I'm going to make up a number because I can't do the trig in my head, but that looks to be about a 45-degree angle. So if you pull up 100%, you're only getting, I think, 70% of the force in on the brakes. If I'm doing my trig right in my head. I think I just did. Sorry, Bruce, if I didn't. But anyway, you're getting a decreased amount of force. So what I did was, I'm like, I wonder if I can put V-brake. I think, surprised that these are called V-brakes. I don't know why, that's shaped like a V. But these are called V-brakes. They're also called linear pull brakes. I wonder if I can put these on my bike. So I went online, did a little research. And there's plenty of people with their opinions online. But the opinion I kept seeing, upgrading your rim brakes for cyclocross, part of the problem is, up till 2 years ago, so anybody race cyclocross or go to a cyclocross race in town? Yeah, they're fun to go to, wicked fun to go to. The UCI, which I'm not sure what that stands for, but I think it stands for a bunch of French people that make extrapolated rules for no reason. They said you had to have cantilever brakes on cyclocross bikes up until 2 years ago. They wouldn't let bikers put any other kind of brake on. Like disc brakes would be perfect for this kind of thing. Now because, you might have noticed, you probably didn't notice actually, this bike doesn't have disc brake tabs. There's no place to put disc brakes on this bike. It's a carbon fork first of all, so we're screwed there, unless they retrofit some kind of a steel connector. So I couldn't put disc brakes on. So my choices were, leave the cantilever brakes on. Safety-wise, that wasn't a choice. My ride home from work, I ride up past the dorms, there's a trail that goes above Juniper Hall. I get up on Glasshouse Street, and then I come down at Summit, right? Summit Drive. I go through Sawyer Uplands Trail, which comes up by that Yosemite Drive. It's a very steep, hilly series of switchback dirt. I've laid that bike down on those trails like 4 or 5 times. I get into those switchbacks, and I'm buried. The levers are buried, and the bike's not slowing down. So I'm like, well, let's throw the bike down and run away. I'm like, it'd be better to do that than keep going faster and then eventually pitch into the river. So there's got to be a better way. Now mechanically advantaged, there's got to be a better way. Some people would say drive. But so mechanical advantage-wise, the V-brakes are better. And I don't know if you can kind of get a feeling why. When you pull, yes, that's it, Angie, you got it. When you pull the lever, this pulls directly across. Directly across means the pads are moving in the same direction the cable is, which means you essentially have zero loss of that force. Disc brakes are even better, obviously, because they go like that on a disc, which is why your cars have them. Your cars don't have this. I mean, imagine if your cars had these. Well, they wear out in like 5 feet, and we'd all be dead. So this is obviously, given my choices, I have cantilever brakes, which obviously, these are the exact ones that were on my bike, and they were terrifying. I could upgrade the cantilevers, which apparently have a slightly better mechanical advantage, but V-brakes have a better mechanical advantage than all of them. Disc brakes were out. I couldn't go with disc brakes. I could go retro and put a coaster brake on the back, I guess. Build up a coaster brake, and then they'll kick back brakes from the little Schwinn Stingrays you have when you were a kid. So this was my option, but the question was, could I use it? Because again, because there's a mechanical advantage difference, the levers might give the wrong amount of cable pull. So that's why I went online, looked through some research, can I just switch out the brakes? So here's lots of, I was going to set up my cross brakes with V-brakes, but notice that no one uses them. Well, that's because the French said you can't. I know the newest 105, blah, 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 relevant threads, I've necessarily cross-checked straight bars, V-brakes, this guy has V-brakes. But what I noticed over and over again was people kept saying you have to put mini V-brakes on. Now here's some more physics for you that you can probably forget about as soon as I tell you. Mini V-brakes have shorter arms than full-size V-brakes. Now V-brakes were the bomb in the 90s. Like this was the brake to have before disc brakes got it. Disc brakes weren't always on mountain bikes. I mean, it's a relatively new phenomenon. V-brakes were the bomb, other than hydraulic rim caliper brakes, which are even better. But you can't mount those on these. So what the threads were telling me was, I have to use the mini V-brakes versus the longer V-brakes, because remember the cable problem with the cantilevers? The mini V-brakes mimicked the amount of travel that the cantilever brakes had. The big normal size V-brakes, and I say big, they're literally 3/4 of an inch longer. That was too much. They said if you do that, I forget what it was either too much force or I think it was too much force. Jack's saying yes, because that makes sense. You make the lever arm, it's the same thing you use every time you use a lever arm to do something. Use the lever arm, Archimedes, give me a lever long enough and a place to stand, and with my own weight I can move the world. You know, if you've got a 20-foot steel bar, you can raise your car off the ground if you needed to. That's the point of a lever, right? So that brake is a lever as well. So if you make the lever arm longer, that means the force is exaggerated, which means the same distance, the same force is going to be exaggerated, which means it's going to go too far. So I said, okay, maybe I should get these mini V-brakes. Then I stopped for a moment. I said, wait a minute. First of all, if I buy them, can I return them if they suck? Check, yes. Store said yes. Secondly, let's be statistical about it. So, what I did was, my neighbor's house, across the street from mine, very nice, large, steep driveway. Here's an aerial view. You can see it right here. There's my house. No, that's my house. It's solar panels, of course, because I'm city. So, there's the pond me and Max drill holes in and ice fish with in the winter. So, I set up an experiment with him. Ran a tape from the end of that driveway right there all the way across the road. Took me and my bike with the old brakes before I swapped them out, to this point where that car is. The car wasn't there at the time. I was sitting right where that car was. Got into a track stand, let go. Gravity pulls me down the hill. Didn't pedal, got into slightly a tuck. Something that I can replicate every single time. As soon as my front wheel hit that line where the tape started, was it front or back? Whatever it was consistent. I then applied the brakes. I applied the brakes, so I tried not to skid. Skidding would throw the results off. So I tried to come to a full stop in a controlled manner. Okay, Max helped me measure. He would go out and he'd find where my front wheel ended. He'd put his finger down and he'd write down the data. Okay, there's my data. I did it first with the cantilevers. That was a before. And then I did it after with the linear pull, with the mini Vs. These are the Tektros that I put on, the mini Vs. So my question is, number one, are they better? And number two, if we can go even further, how much better are they? How much better are they? If you had to give a number for how much better are they. So there's my data. What do you think? Can we answer this question? Give me some initial thoughts. Give me some initial, just shoot from the gut. You can grab your TIs if you want, absolutely, but shoot from the gut right now. Skylar says, yeah, they're better. What?
I don't know, all those ones seem to be like in the 20s.
20s?
And then we just have 20s.
Teens, right? High teens, mid to high teens versus 20s to low 20s, sometimes mid 20s even. Yes, there is some variability issues, and that is a part of the problem of answering this question. Variability issues. We could very easily do what with this set of data? Find its, of course. And we could very easily find what with this set of data? Good, and we can take the difference of those two averages, yes? Is that good enough for significance? She's really kind of depressed, like, no.
In the real world, yes.
No.
In Sean's world.
In the crappy world of core science, yes. But why is that not good enough?
There's a margin of error.
Because there's a margin of error. I stopped the bike, what is that, 20 times? This is essentially when Max lost interest and we had to go inside. So I stopped the bike 20 times because I have a random sample, which means I've got sampling error. Nah. I don't know if there's any outliers in there. I did note that I did skid on the 14.4. I felt bad throwing it away because Max was working so hard to collect the data.
Oh.
So I felt bad about, I didn't know whether we should include that or not. My guess is no. Because it was a skid, it didn't operate like the other parts of my ride. The other rides were all control braking.
Isn't that
No,
good to know though?
Yeah, that's.
it's good to know that it is a skid. That's what I'm saying. So I labeled that as such so we can decide if we should toss that.
Well, it's good to know that it made you skid though.
Oh, I can make any brake skid.
Okay.
I mean, it's very easy on this. Speaking of which, those of you that use the mountain bike trails on Phil's Trail, for example, please don't skid. Those of us that work on them, we have to then fix that. So you can make any bike brake skid. If you're going fast enough and you slam on the brakes hard enough, you can make a skid. When I laid my bike down, I was trying not to skid. I mean, I could have locked the brakes up, but locking the brakes up on a downhill mountain bike trail, you're gonna slide off the trail anyway. I want to keep the wheel rolling and slowing down. So that's why I figured we just leave it in there and we decide if we're gonna keep it or toss it. So I guess the question is. So we have a couple votes. I heard at least one vote said the V brakes are looking better. We got a couple nods, yes? Anybody you can say it, okay, we're going V brakes are better. How much better?
I don't know. It's faster. I don't know if that's better.
Ah, good, very good
It's
point.
basic
It takes
better.
less time to stop. We're gonna define that as better. Thank you. Very good point. Define better. Now, good, and I was taking that for granted. If I come to a full stop with essentially the same speed in less time, i.e. less distance, we'll call that good. Thank you. That's important to know. It's important to know. So, let's start crunching. Let's start crunching, because I also want to know how much better do you think, on average, are we doing? I'm going to shut the camera down. Let's start crunching, okay?
So that means we